We are Cosmic Queries. Talk after hours. I like to think of it. I would never do Cosmic Queries alone. I get Chuck Nice to join me.
Yes.
Chuck Nice Comic.
At Chuck Nice Comic, that's me. How are you,
That's
Neil?
what they call you in the Twitterverse.
In the Twitterverse.
Yeah.
I love that word.
Isn't it great?
Twitterverse.
I can put a verse on everything, and we take ownership of it in the universe.
There you go.
Yeah.
Yes.
The Chuckiverse.
God, that's scary. The Chuckiverse is scary.
And so, thanks for being on.
Absolutely.
And you got a TV show where you just bust into people's homes?
Yes.
That's crazy.
I love
How did it even let you do that?
You know, I ask myself that question every time I'm on it.
Exactly.
Like, how did this happen? But yes, the show is called Home Strange Home, and I pretty much invade the homes of unsuspecting people, show up with cameras, and they take me on a tour of their weird, wonderful house.
And you just talk about them.
And seriously, I do.
Home and Garden TV. That's my sister's favorite TV show.
I love your sister.
I mean, her favorite TV
network.
Yeah.
Yeah.
And she'll find you for sure.
I love her.
So we got questions. The topic today is on time
and time keeping.
Time reckoning. And so we solicited questions from the internet.
Yep.
We've got our website, startalkradio.net, and we're at Star Talk Radio on Twitter,
Right.
and we're in Google Plus.
Yep.
And so I
got questions from all of those places: Twitter, Google Plus, Facebook.
Bring it on.
And Star Talk Radio.
And if I can answer anything, it's not the point of this is not to stump me. It's just if I have answers, I share them.
Right.
And otherwise, I'll just say I have no clue.
Okay, cool.
All right, good.
So now I have a question, and okay, here's the question. All right, is time infinite? Okay, and so I'm going to. This is Scott, and this is Milad. These two questions. One, is time infinite? And so I might as well ask Scott's question along with that, which is, what is time? And now here's the third part of that. I believe time doesn't exist. So
that's
the third part. I just want to know if I'm right or wrong.
The theory, according to Chuck, time does not exist.
That's my theory. That's my personal theory, is that time doesn't exist.
Okay.
But the question is,
we have evolutionary theory, quantum theory, and Chuck's theory.
Yes.
Just to put this in context. What you really mean is you have a hypothesis.
I have a hypothesis.
Really exist.
Yeah, because it's really not a theory.
All right.
I have a hypothesis that time does not exist.
Einstein described time as being defined to make motion look simple.
Wow. That Einstein dude was kind of deep.
He was deep. And in physics, what we really care about is not what is true. Yes, that's fun over a beer. But what we really care about is, how does the universe reveal itself to us in ways that we can calculate and then understand what we see and make predictions about what is yet to be tested? Mm-hmm. And so we're dependent on our interaction with the universe. And so if time is a thing, if we can define it in a way to make motion look simple, we're all over it.
Right.
All right. And so time is not infinite. Time as we have defined it had a beginning, and that was the Big Bang.
That was the Big Bang.
If it was infinite, it would have go to the infinite past.
Correct.
But it has there's a stopwatch that got started at the Big Bang, the birth of space and time, matter and energy. Now, as far as we know, we're going to expand forever into the future, and if that's the case, time is what we call semi-infinite. It's infinite in one direction, but not the other.
Gotcha.
It's an actual math term, semi-infinite.
Semi-infinite,
yeah.
right.
And so
it's like a number line.
No, like a number line.
Like a number line.
You start
at one point, and then boom, you just keep going.
Semi-infinite, half infinite. Like a semicircle is half a circle.
Right.
Yeah, semi-infinite, you're half infinite. Is that good?
God, that sounds so counterintuitive. You are semi-infinite.
You are only half an infinity.
Right, you're only half of infinity. It's like, that's really cool.
And so in that, as far as we know, time will continue going forward forevermore.
Right.
And so there you have it. Now the Chuck theory, right along with quantum theory.
My hypothesis, yes.
Thank you, is that time does not exist.
It doesn't exist.
And what's your evidence for this?
Okay, so think of it this way. If there were absolutely nothing, then there would be nothing to measure, and therefore time wouldn't exist. That's what I'm saying.
Oh, okay. So what you're saying is time is a construct of the places where there are things to measure it.
Exactly. Okay. That's my point.
I'll give you that.
Oh, really?
Yeah.
I'm right.
No, why? Okay.
No, I'm going with right.
No,
I'm going with
Let
Neil
me
says I'm right.
explain. I must explain.
No, don't explain. It's too good. I love it too much. I'm going everywhere now. Neil deGrasse Tyson said my hypothesis was right. So screw you, buddy.
Okay.
I can't wait to get to a beer tonight.
All right, no, so here
by
it
the
is.
way, you know time doesn't exist, right?
All right, here it is. We measure time with phenomena that repeat.
Right. Okay.
The clock dial turns. Initially it was astronomical referencing. Right. The sun
goes around.
Yeah.
I mean, Earth goes around.
Well, that's what we thought. So the sun would go around the Earth, the moon goes around the Earth, this sort of thing, and you'd reckon time in these ways. And then we found you could track time to a vibrating atom. Something's got to repeat.
Right.
All right. To measure time. So you could pose the following comment that if there exist places where nothing repeats, then you cannot reckon the passage of time.
Right.
With any kind of reliability. Not only that, getting back to the Chuck hypothesis, you can imagine a universe, or perhaps outside of our universe, where there is no matter, there is no space, there is no energy. It's just that which is not those three.
Right.
And if it is that which is not those three, and all three of those conspire to allow us to measure time with tools, then where there aren't those three, time would in fact have no meaning.
Exactly.
That's exactly what you were thinking.
That's what I'm thinking. Awesome. God.
Chuck, so I'll give you that, Chuck.
Yes.
But that doesn't mean it doesn't have meaning in our universe, but in some meta place.
In some meta place, right.
Yes, you got it.
Yeah.
I'll grant you that.
Okay, now we're going to have to take a break because I got to tweet that right now. I'm tweeting right now as we speak. Neil deGrasse Tyson said that my theory about the non-existence of time...
It's getting to his head. Yeah, so you've been dropping questions in my lap, and that last one was a good one. I have more to add to it. What was it?
The question really simply was, how would a spacefaring people keep time?
Yeah, and so the good one, my favorite example of that is the Apollo astronauts that went to the moon. Who are they talking to?
Talking to Mission Control at Houston.
And Houston. It's Houston time.
It's Houston time. That's hilarious.
They didn't say, hello, Pakistan.
Right.
So they kept time. They kept Houston time. And on Mars, what
the
time?
rover.
Right. Mars actually has its own clock, which is slightly different from Earth clock. Right.
Really?
The Mars day is slightly longer than Earth day.
Okay.
All right. And so that matters because the rovers that are there need sunlight to drive their solar panels. And so Mars professionals who study Mars keep a wristwatch that is Mars time and not Earth time. And they slowly migrate out of phase from one another. And because if you don't match perfectly, you slowly migrate.
You drop out of phase.
You drop out of phase. And so astronomers on Earth studying Mars are on Mars time with sunrise and sunset at the location of the rover that they're studying. That's cool.
That's very cool.
Yeah. And on the International Space Station, each module is put up by is supported by a different country and nationality. Their time is the time, but from their home base. so the Russian capsule is like Moscow time, right? It's not New York time.
So there's 5 different time zones on the International Space Station.
The International Space Station.
Oh, that's cool.
And here's the question of all questions. If a time zone is separated by sort of degrees of longitude, right? Every 15 degrees, multiply 15 by 24, what do you get?
Oh, God, I couldn't do that.
This would not take God to answer. It just takes the times table.
So let me see. That's 240 plus 5 times 24.
Yes,
so it's 120. So 240 and 120. So that's
nice. Chuck gets it. It comes in at 360.
Yeah.
So all 360 degrees of the Earth are split into 24 time zones, basically at 15 degrees of width, right? So as you crawl east-west, you can change your time zone. As you come near the poles, the time zones get narrower and narrower and narrower. And on the pole, every single time zone converges. So what time does Santa keep on his watch?
I'm going to say poll time.
Poll time. There's hammer time. Now we got poll time. Yeah, you'd have to invent some time. There is no day.
Right.
There's 6 months of sunlight, 6 months of dark.
Right.
The concept of a rotating Earth loses meaning on the pole where there are no time zones.
That's weird.
Yeah,
That's
yeah.
great.
Yeah.
Very cool.
What else you got?
All right, let's move on here. Okay. This is a good one.
Oh, by the way, I got to add one other thing. If you had an actual colony, space colony that was nowhere near Earth,
right,
and you didn't care about Earth, then you're not dependent on the rotation of the Earth or daylight or nighttime. You can create whatever kind of days you want. Studies in psychology showed that if you lock people away and had them set up their own cycles, that their day is typically 25 hours.
Really?
25 and a half. That's why you never quite feel right. Like
Right.
the day is always a little bit ahead of you.
Yeah.
It's because you really want a 25
an extra
hour.
hour.
You need an extra
hour.
You need an extra couple hours.
And I thought I was just hungover.
That's right.
Okay.
By
Here
the way,
is
long ago, Earth's day was longer than it is today. We've been slowing down.
Oh, okay, because of the rotation.
Yeah, did I say longer? I'm sorry, I missed it. We had a faster
day.
Yeah,
Gotcha.
Mhm. Okay, but go on.
Okay, so now here, I don't understand this question, and you're going to have to take me to school on this one. Summarize the timelessness of a photon.
Oh, beautiful. That is beautiful. Are you ready?
I'm ready.
Are you ready for
I'm ready for this.
No, you're not ready. I don't think
You
you're
sound like
ready.
Beyonce.
I don't think you're
Are you ready for this? Okay.
Are you ready for this?
Tell me, are you ready? I'm ready.
No, you're not ready.
I'm not ready?
No, tell me again.
Okay, I'm ready.
All right. You should know, if you study relativity, Einstein's relativity,
Right.
that as you increase your speed, time ticks more slowly for you than it does for anyone who's watching you.
Right.
All right. This is the relativity of time. And this is well known. We've measured this. This is not. It's not just your clock that's ticking slower. Your metabolism is unfolding more slowly. Your brain synapses firing more slowly. Everything about you is slowing down. All right. As you travel faster and faster, get closer and closer to the speed of light, you age more and more and more slowly. Time ticks more and more slowly for you.
Okay.
If you hit the speed of light, which we don't know how to do yet, but if you ever hit the speed of light, then time stops. Photons, which is the carrier of light,
Right.
exists at the speed of light. It doesn't accelerate from 0 to speed of light in 3.4 seconds.
Correct.
It exists at the speed of light. And because it exists at the speed of light, any watch that it's carrying never ticks. Which means if you are the photon, become the photon. If you are, this is not a proton now,
right,
particle in the nucleus of an atom.
Right.
The photon, the particle of light. If you are a photon and you are emitted from across the universe,
right,
you will be absorbed. You will slam into whatever you are destined to hit, as far as you are concerned, instantaneously. That's correct.
Right.
Because no time would have elapsed.
Because no time's right. Because you can't, because at that speed where you exist, that speed, time has stopped.
It stopped.
So for you, time doesn't exist.
Time does not exist.
Dude, this is mind blowing.
Time does not exist.
Oh, yo, man.
Okay. Now.
No, wait a minute. You gotta give me a second, man.
You gotta absorb that.
Nah,
okay.
that was great.
Now.
Yo, anybody got some weed? I need some weed right now.
Good for you?
That was cool.
Some people would have requested it in advance of this. Let's all move to Colorado and get the weed, right?
Exactly.
So it's why we knew that the neutrino could not be traveling at the speed of light, because the neutrino actually changes species midway.
Gotcha.
There's one kind of neutrino that can become a different kind of neutrino species. Mm-hmm. How would it know to do that? Unless it's keeping track of time.
Exactly.
It knew to do this. It does that at a predictable interval. It can only do that if it's carrying a stopwatch.
Wow.
So we knew the neutrinos were not traveling
at the speed of light.
Because if they were, they would never change.
Wow.
They would not
so
know
now,
to change.
This begs the question. I'm going to take Todd Smith's question one step further. So if you surpass the speed of light, does time go backwards?
Yes.
No!
Yes.
Get out of here.
And we invented a particle that we would call, if we found a particle that did that, we have a name for it. They're called tachyons. From the Greek root for the tachometer comes from that.
Yes.
It means fast.
Right.
Okay. And so this proposed species of particles only ever exists faster than light. And they can travel infinitely fast. They would go backwards in time. If I sent you a tachyon signal, you would get it before
you sent it to me.
Correct. Right. Imagine messing with the tachyon and say, oh, it's fake. Never mind. It's like, oh, what are we going to do?
Wow.
Yeah, so tachyons travel faster than light and move backwards in time. And it's perfectly consistent with Einstein's relativity. We're cool with that. We just never found them before.
Awesome.
We don't know if they exist, but it works on paper.
All right. Okay.
So time for one more question before this.
Real quick. Mark Swift, why hasn't time been decimalized?
Ooh, it was decimalized.
What?
Yes, in the French Revolution. Did you know that they had decimal time in the French? Did you know that the metric system is conjoined with the French Revolution?
I did not know that.
The French said, as long as we're taking stuff up, let's fix this crap, these fractions. This stuff that came out of England with the pints and the quarts and the this and the fifth and the dram and all of this. So they decimalized everything. And they got a little carried away because they wanted to decimalize time. So they turned a day into 10 hours, an hour into 100 minutes, and a minute into 100 seconds. That's correct.
So under that, you get a 10-hour day.
Yeah, it's a 10-hour day. So they decimalize time, and if you do it right, if you do the math, the number of seconds in a decimalized day is about the same, like within 10% of the number of seconds in a normal day.
Right.
So you wouldn't have to do much to redefine the second. You just have to get people accustomed to decimalized hours and minutes and where else? Google Plus? We're everywhere.
Yeah, we got Google Plus. We got Facebook. You name it.
Name it, we're there.
Pinterest, YouTube. I mean, we're not taking questions from there, but we're still there.
We're still working it. Yeah. All right. So what do you got for me?
All right.
Oh, we're talking about time reckoning, I guess. Yeah.
Yeah.
Uh-huh.
So I think, all right, here's a funny question. So this is from Jeff Sloan. And Jeff says, just an interesting thought that I had that I would like you to explore or completely debunk. If objects moving faster than the speed of sound can cause a sonic boom, is it at all possible that the Big Bang was a result of something traveling faster than the speed of light? If I'm correct, please provide an address where I can pick up my Nobel Peace Prize.
Okay, first of all, the Peace Prize is not given for discoveries in physics. That would be the Nobel Physics Prize.
Aha!
Just to clarify that.
There you go, Jeff. Sorry, buddy. No Peace Prize for you, no matter what.
No matter what. Occasionally a scientist can win a Peace Prize, but it's rare. It usually goes to a politician in power.
Right.
Or a dissident in power.
Right.
Right. So what do you want? So he wants to know if you can get a sonic boom, a light boom. Yes.
Basically a light boom is what he's talking about.
The answer is yes. It's called Cherenkov radiation.
Dude, you are killing me.
Yeah. Yes. If you travel faster than light, there is the light equivalent to a sonic boom, where the light pulse builds up on itself, and it's a flash of light, and it's called Cherenkov radiation. Now, but since you can never travel faster than light, you might ask, how does one come up with this stuff?
Exactly.
Here's how it works. If you have light traveling through water, transparent water, light travels slower through water than through a vacuum. It travels so let's start. It's fastest in a vacuum.
Right.
Travels a little slower going through air.
Right.
Travels a little slower going through water.
Right.
Travels even slower going through glass. Travels even slower going through diamond.
Okay. And of course, that is because it is both a wave and a particle.
Yeah, it's trying to get through the medium. Trying to get through them. And in fact, the diamond, I remember my number, it's 40% as fast in a diamond as in a vacuum.
Wow.
Yes, it's
That's
slow.
a huge difference.
That's what makes diamonds so cool. So if you put facets in the diamond at the right angles, at the correct angles, because the right angle would be 90 degrees, at the correct angles, because what we call the index of refraction is so large, because light travels so slowly in a diamond, that it bends back on itself multiple times within the angles that you can create on your ring, and then it shows up again in a different direction. So that's why a diamond looks like it sparkles. Because if it was only light coming from where the light came from, you'd say, well, that's just the light I'm looking at. But if it comes from a new angle, you say, hey, that diamond is sparkling, is talking to me.
Right.
So, all right, so now you have light going through all these media. Now you send a particle through there faster than that speed. That will create a mini sonic boom, except it's not sound, it's light, a mini light boom, and it was first described by the physicist named Cherenkov, and he won a Nobel Prize for this discovery.
Look at that.
So tell him the Nobel Prize has already been claimed.
Sorry, Jeff, your prize has been claimed.
Okay.
You were right, but somebody beats you to the punch.
Wait, but let me get back to the Big Bang. So the Big Bang was an expansion of the universe faster than light, but it's not the universe expanding faster than light in a medium.
Gotcha.
It is the very fabric of space and time itself expanding, and you don't get Cherenkov radiation for that.
From that. No. Okay, right, because it's actually happening in the vacuum, which is space.
Well, no, I mean, all of space is the explosion. It's not a vacuum within the space.
Oh, okay, so the space itself is the explosion.
Is the explosion, exactly.
Gotcha.
Duh.
Look at that. That's awesome.
Right, okay.
All right, let's move on. Okay, I love this question too. This is Theo Potter. What would actually happen to the planet if Superman made the world spin in the opposite direction like in the 1978 movie? I'm assuming our gravity would shift and time would not rewind.
Oh, okay.
So now let's just say, for instance, you can spin the Earth backwards.
Okay.
What are the results?
All right, so while Superman was flying around the Earth the opposite way, and we saw the Earth slow down, well, okay, the Earth is going, if you're at the equator, you're moving 1,000 miles an hour on the rotation path that the Earth brings you. Right. If you slow down from 1,000 miles an hour to 0, excuse me, if you're not wearing a seatbelt connected to Earth, you're going to fall over and roll due east at 1,000 miles an hour.
So you mean the whole Earth, everything on
Earth that's not bolted would fall over and roll due east.
Right.
Commensurate with the speed that it had going east-west at the beginning of this. Santa would be fine.
Right, because he's up on pole time.
On pole time.
And he's chilling.
He's chilling on pole time. So everyone would just fall over, and then you'd stop the Earth, and then spun it back, and you'd fall, but you'd roll back the other way. So we'd be completely battered from this process, and nothing would have happened to time, and our gravity would remain exactly the same.
So basically, nothing would have happened to time. Nothing happens to gravity. We're just in a huge planetary auto accident.
A train wreck of an auto accident. Your home astrophysicist with Chuck Nice.
Yes.
Chucky baby. Tweeting at Chuck Nice Comic.
That's correct.
Yeah, so we at the intermission, before we did that, we were talking about Superman's feet.
Right. We had
not his feet, but
his feet of spinning the Earth backwards.
Thank you. Not his anatomical feet. He spun the Earth backwards, reversing time.
So Theo Potter had said, wanted to know what would happen if the Earth actually went backwards, and you answered that. But Clarissa Wegner actually says, at Theo, I think what happened was that Superman didn't reverse the spin of the Earth. He was just going so fast that he himself went back into time and was able to do whatever he had to do. So,
okay.
So not the Earth spun backwards. He went backwards into time.
Okay, so this is who?
Now this is Clarissa.
So Clarissa is talking to Theo, and we ain't even in that conversation.
They are having their own conversation.
Damn, sorry, Theo, I didn't get your answer fast enough. We got other readers jumping in on it. So I remember when I saw that movie because my girlfriend at the time, I'm people's own astrophysicist, right? So they asked me the questions. So she said, could that really happen? She asked. At no time else in that movie did she ask me if what she saw could actually happen. Like, could a man in blue pantyhose fly? That question did not come up. All right. Can he block bullets off his chest? That question did not come up.
Right.
But can he go back in time? That came up. So could he have been taking himself back in time? But why would we watch Earth slow down, stop, and reverse? You can't go back in time yourself.
Okay.
And, well, unless back in time we are revisiting the Earth at that rotational phase. Okay. Now that I think about it.
Yeah.
I can let that go.
So Clarissa has some legs here?
He is not turning Earth backwards.
Right.
He is going back in time, rewinding the clock.
Right.
So Earth didn't actually stop.
Right. That's what Clarissa is saying.
I got to give her that.
Clarissa's onto something.
Clarissa, you're onto something.
Look at that.
I'll give you that. Okay. Now, why she would do that for Lois Lane, that's a bigger question.
Oh, that's rough.
Sorry.
Cold-blooded. Okay. that was cool.
No, we need Lois. Sorry.
All right, cool.
Plus, I met Superman in the comic. You didn't see this comic. I was in the comic. I was in the Superman comic. Me and Superman were chilling.
Yeah, man, I think that's so cool.
But Lois Lane was not there. I didn't meet Lois Lane. Maybe I feel differently about her if I got to know her as a person.
I'm just glad that you didn't meet her, because that would have been awkward.
Okay.
All right, here we go.
Yeah.
I've been hearing a lot about this. This is from Jordan Navarro. I've been hearing a lot about this theory that if we place a giant mirror 22 light years away and point it at an extremely efficient telescope, we would see things happening in real time in the past. That's what he's saying. Since the mirror is 22 light years away, wouldn't it still take that light 22 years to travel back to the mirror? So I think what he's saying is, if you were to put a mirror 22 light years away from Earth, point it back at Earth, would you be able to see Earth 22 years in the past?
No, you would see it 44 years in the past.
Right, because it's got to go there and come back.
Do the math.
Yeah, you got to look at it, and then it's got to come back to your eyes.
Exactly. So you see yourself in a mirror, not as you are, but as you once were, 2 billionths of a second ago.
Gotcha.
If you're a foot away.
If you're a foot away.
Light travels a foot every billionth of a second.
Okay.
1 foot per nanosecond, if you want to be exact. Where you came up with the number 22, I don't know. I'd stick a mirror out there, let the light go and come back. You will see however many light years away. Double that, because it's the round trip time. That's how far in the past you were viewing events on Earth.
So you're viewing the events you're actually looking at the past in real time for you.
Yes.
Gotcha.
Yes.
Gotcha.
That's exactly what's happening. That beam is on its way to the mirror, and it's on its way back, and you're catching it.
Right.
All right, that's all. And by the way, we see other objects in the past because their light has just reached us. So this is not magical thinking.
Right.
My favorite is a galaxy that's 65 light years away. I'm sorry, 65 million light years away. It's a galaxy called M100. M100, 65 million light years away. We're back on Talk Radio. I'm Neil deGrasse Tyson with Chuck Nice.
Yes.
Chuck Nice, comedian.
Yes, sir. Yes, sir.
No, that'd be female comedian.
I was going to say, well, I'm a little of both.
A little both.
I'm a little both. I'm like a little country and a little rock and roll.
All right, there you go. Thanks for being here. I couldn't do this without you. You're reading questions to me from the internet and all of our internet presence. And this is our last segment. We hardly got through any of these questions.
Yeah, so we got through a goodly amount, but you know what? Because we're going to try to get to as many as possible now, we're going to call this our lightning round.
Lightning round. So now you want me to answer fast?
It's just, look, if we get to it, we get to it.
All right, I'll try. All right.
So let's jump right into it here. We got
the lightning round.
The lightning round.
I need a bell. Ding. Let's go.
Stephen Castaneda says, is the perception of time universal, or do we all perceive time differently? I wonder if a housefly and other organisms perceive time to be quicker. So shorter lifespan, shorter time span? I mean, you know what I mean? Like,
it's fun to think about other life forms that live shorter or longer as perceiving time differently, but typically when we do that, we are humanizing their life.
Right.
So 1 dog year is 7
human years.
Yeah, dogs don't care about humans. Why do they care? So, but the passage of time, as measured by the atomic vibrations of atoms within them, is the same for everyone.
Okay.
Oh, yeah.
So that's it. On an atomic level, that's it.
That's it.
No difference.
You can slow it down, speed it up with relativity, but otherwise, if you put the frog and the mayfly and the human and the elephant together in a room, the passage time is the same.
I got you. And that makes great sense for dogs, because that means a dog would be licking its butt for about 2 months.
Total out of its life. If it were a human, yeah.
Right. Mm-hmm. Okay, here we go.
Keep going.
Samir Schumann, would time exist without motion?
No. Next question.
Oh, crap.
Well, no, it could exist. You could never measure it.
Gotcha.
And not only that, you'd have to be able to measure it with motion that repeats. If it's motion that's non-repeats, you'd have no real way to measure it.
Okay. All right.
Got it. Next.
Here is Tom Shilson. And Tom Shilson asks, is there any evidence?
No. Next. Wow, you're lightning round.
You're good at this.
No, man. Go.
Okay, no. Is there any evidence that time is broken into little bits? Now, this guy's he's going on some space-time continuum trip now, man. So here's what Tom says. Can time be broken into little bits?
Yes.
What?
Yes. I said no, but the answer is yes. All of our understanding of the nature of reality tell us that time is quantized on the smallest scales. It is quantized so that time, it does not pass continuously, but there's the smallest possible unit of time you can measure, and you need quantum physics to recognize that. So yes, time gets quantized.
Oh, man, we don't have time for my follow-up question.
Go. Next.
Okay, here.
Bring
no, I got to ask my question.
This is the lightning round. Go. Okay. Then I'll lightning round you. Go.
All right, here we go. Joey Carasone. Joey says, if light...
Hey, Joey.
Joey. If light can't escape a black hole, how would time be affected inside the black hole? So now you got a force that is stronger. The gravity is stronger than light itself.
As you fall into a black hole, time ticks more slowly for you. And you look out to the rest of the universe, and the rest of the universe goes by quickly. In fact, as you descend to that cosmic abyss, moments go by for you, and trillions of years go by for the universe itself. You will outlive the universe in your descent to the center of a black hole. Next.
Whoa! Dude, that's awesome. Okay.
In lightning round, there's no time to comment on whether it's awesome.
There is no comments in lightning round. Okay, here we go. If you were living in an era without time keeping as we know it, how would you map out time?
I would map out time by asking what happens before what. So you're a baby before you're an adolescent. You know, you can sequence events, even if you cannot measure the interval between those events. And that way you get some sense of the ordering of life.
So whatever is measurable, that's what you use to measure.
No, you don't even measure. You say this happened before that.
Well, that's what I mean, sequence. Whatever is a sequence, that's what you use.
Right. Okay. You just sequence it. And so that's what you do.
All right, let's move on.
Next.
Here we go. Danish Memon says, is the universe necessary for time to exist? For example, was time present within whatever came before the universe?
Time, as we have defined it, exists only within this universe.
Gotcha.
If we go outside of our universe, we'll have to think up something else to keep track of things. Maybe there's some meta time that we can think of, just the way we can think of a multiverse,
right?
A word bigger than the word universe itself. Maybe we are longing for that word, such as meta time, that can accommodate our measuring needs when we exit this universe in which we're born. Next.
Jeez, that was good. Man, you're just making this stuff up.
No. We're running down quick. I got one last one.
All right, here we go.
Knock it out.
Is there a place in the universe where you could still see the Big Bang happening? In other words, can you still see the Big Bang?
Yes, we see it now. You look far enough away, the light from the Big Bang from a distance 13.7 billion light years away is only now just reaching us. Everybody looking in every direction. Look, if you look far enough away, you see the birth of the universe.